So Darian, yes, ma'am.
I have a suggestion.
Okay.
So, the ones we don't get through today, could you maybe make a video of them so that on Monday we can just review and we can watch the video of the rest of them over the weekend? Unless you guys don't.
I was going to say that's not very hard for me to do, but your classmates might not like that.
It's like he makes a video of the rest of the last 5 months, so then on Monday we just review instead.
So if you don't watch the last 5, you can just turn your own test scores.
No, you can decide by the end. We can decide that. So Darian, you mentioned, hey, maybe we could do L'Hopital's rule here. You could, except it says use the Maclaurin series for sine to do so. If you wanted to check, you certainly could. And I got to be honest with you, I think it would actually be faster to use the series here.
Okay.
To be honest with you. So obviously, if you look at that limit as it stands, you're going to get a 0 in the denominator, and specifically, I guess, 0 over 0. So that's why you could use a L'Hopital. But do use the Maclaurin series, which McKenna so expertly put up there for you, to see if you can evaluate this limit, bypassing L'Hopital's rule, at least to some degree. See how it goes.
Yeah, it's going to be great.
Maclaurin series to do this. That equal sign is so important because I think even at this stage, I mean, you guys have obviously done a lot of math in your lives already, but I think it's easy to forget what the equal sign means. It means that those two things are equal to each other regardless of how they look. And the important thing here is if two things are equal to each other, one can replace the other, right? So my thought is this. If I'm going to use this Maclaurin series to accomplish the evaluation of this limit, I'm going to write limit as x goes towards 0. And then in place of sign, I'm going to put that. I'm going to put what McKenna put up there because it's right. So I'm going to say, here's my fraction bar. It's going to be x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. I'm going to put plus dot 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 because I know it keeps going. But I'm not going to write every term because I can't. There's an infinite number of them. And then I'm just going to put minus x. So I know there's a bunch of other terms here, and I'm going to hopefully figure out how this is going to work with this minus x, still over x cubed. So all I've really done here is just, I don't know, how would you describe what I've done? Like what process did I use to get that? Substitution, right? I replaced something with something it's equivalent to. So then where this hopefully will fall into place is we can see that x, positive x, minus x, those will just simply add out. I'd be left with limit as x goes towards 0, x minus x being 0. Now I'm going to just be leading off with negative x cubed over 3 factorial, 0. Here we go. I'm getting ahead of myself. I got to do some dividing here in a second. Blah, blah, blah. And now I've got over x cubed. How does this x cubed come into play? Well, that pattern continues. For me to divide out the x cubed, I need to divide it out of every single term. And so that's going to really leave a very distinct pattern. It's going to be limit as x goes towards 0. And the first term is going to be negative 1 over 3 factorial. The next term is going to be x squared over 5 factorial. Then minus x to the 4th over 7 factorial. And the important thing about the plus dot 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 is that every single term from there on out, no matter how many I decide to write, won't every single one of them have an x? Meaning now, as I apply this limit as x goes to 0, meaning that all these terms are going to go towards 0. And all the whole dot dot dot, they're all going towards 0. All of them except for the first term. And so it's going to end up being negative 1 over 3 factorial plus a bunch of zeros, leading me to just think that it's going to be negative 1 over 3 factorial, aka negative 1 over 6. Make sense? It's one of the things you can do with a series, right? So if a series, this is where, like what we did with that integral last time, this is where if a series really is equivalent to the function that generated it, then you can replace one with the other, and it's okay. And that's kind of the, the discuss why this works part. Since sine is equal to that for an interval of convergence from negative infinity to infinity, I can essentially plug that in without even really being concerned about the interval of convergence, right? Because that converges for all numbers. Zero's right in there, of course. Doesn't really matter for sine or cosine, whichever one we're talking about here. Did anybody do L'Hopital's rule real quick? Just see what the answer should be? Should get the same thing. Yeah? So let's see here. If you tried it, you'd get 0 over 0. So then that would lead you to do limit as x goes towards 0 of cosine x minus 1 over 3x squared, which is another 0 over 0. Then if you do limit as x goes towards 0 of, let's see here, it'd be negative sine of x over 6x. That gives you another 0 over 0, right? And then finally you get to limit as x goes towards 0 of negative cosine x over 6. There's your negative 1/6.
So that's just like another technique to use.
Uh-huh. Yep, just a totally different technique that you could use. Some would say it's easier, some would say it's more difficult. I would say you guys would probably say it's more difficult at this point because you did more with L'Hopital's rule in the past, but it certainly is something you could do. Okay. Well, let's see here. Let's move forward. Yes, 10 and 11. These are good. So 10 and 11 I kind of referred to a little bit last time. These types of questions. And I'm going to let you guys kind of mess with both of these here at the same time. Well, maybe just do 10, I guess. We'll start with that. So this says use a known series. When we say known series, we're talking about one of these four to determine the function represented by that. So someone has created this power series. Our job is to decide what the function might be based on all these. So give it a shot. I can give you some hints, but I'm just going to let you mess around with them for now.
No, wait.
There are three that you could look at. One of them is the factorials, right? Another one could be the exponents on the x's. And then maybe you could be looking at is the series alternating or not. So of those three things, factorials, exponents, or alternating, which do you think would be the best one to kind of give you a good start as to what it might be? Maybe in other words, what's going to be the hardest to manipulate? Factorials, exponents, or plus minus?
Hardest to manipulate?
Because if it's hardest to manipulate, that should give you a clue, right? The factorials. That's really what you want to look at the start. Because if you looked at this, you might have seen, oh, look, all of the exponents are even. And look, it's alternating. And that might have made you think cosine. But you're going to have a really hard time dealing with those factorials. Right? It's going to be hard to reconcile that. So, this one is kind of designed to sort of look like a cosine. It's got a couple of characteristics of cosine, but it's not cosine. It's not. The way we're going to do this is e, right? So I'm going to be looking at the factorials and thinking to myself, all right, for all the factorials that I see down here, which pattern does that fit? Well, e is the only one that goes 1, 2, 3, 4, 5 factorial, right? And so I'm going to start off by thinking, I think this is e. So e to the x, maybe you'd write it down and say 1 plus x squared over 2 factorial, so on and so forth. And so you think, okay, well then how could I make this look like I want it to? Now we start looking at the exponents, and you see the exponents are even, and right now they aren't even. And you obviously look at the alternating piece, and you think, well that's not there now either. The easiest way to do an alternating is just to plug in a negative something, right? Negative x maybe, but that doesn't help you with the even or oddness. And maybe, you know what, part of this could be trial and error. Maybe you just did this. Maybe you just thought, you know what, I think it's this. That would be this right here. And if you looked at it from that perspective, we're part of the way there, right? We've matched everything but the exponents. So then maybe you'd question, all right, well, how could I then deal with the exponents? So this one didn't work very well. Maybe you do arrive at this, which I think is what we're looking at, right? You look at this and you get a 1 minus x squared plus, well, negative x squared squared is x to the fourth over 2 factorial. You're feeling a little bit better about this. You end up with this as you build this back up. And you can now say, I think confidently, that this could be represented by e to the negative x squared. Does that make sense? Start by investigating the factorials. That should give you a place to start. And then you got to start thinking, all right, did they multiply by something? Did they substitute, like in this case? What might have been the thing that was done to get it here? So once you guys try number 11, check that one out. You should be able to use similar kind of reasoning here to get to your function for 11. So, based on the factorials, where'd you guys start with this one? Sine, right? So sine is the one where the factorials go 1, 3, 5, 7 factorial. So, maybe you start off with sine, and, I'm just thinking maybe you'd write down the first couple of terms for sine, and then kind of regroup and ask yourself, all right, well, if that's where I think I'm going, then how is that series up there different from sine? How would you guys describe the difference? Yeah, the degree is 1 less on every case, right? So if I divided this side by x, that would give me, I got to do the same thing to that side, that would give me 1 minus, then x cubed over x is x squared, and we're starting to see the pattern take shape, plus x to the fourth over 5 factorial, and I think we probably have it. So then we could say that that is sine of x over x. Does that make sense? Okay. All right. Do you guys have any questions? Do you see why knowing these series is essential? Like if you don't know these, then I would say 11 is hopeless, right? You have no chance. But if you know these series, then 11 could go well, right? Focus on the factorials, then decide how has it been changed. You got a pretty good shot. Okay, good? Cool. Well, let's move on. I think we're going to skip 11 and move on to 12, or excuse me, skip 12 and move on to 13. Yeah. So I want you guys to check out 13, and I think I want to do this one with you guys. Okay? So this one takes it up a level a little bit. But it does kind of tell you what to do. It doesn't tell you exactly what to do, but it gives you a hint. It says, using integration. So if we go through this whole deal and we don't use integration, we probably have an issue, right? So let's think this through. It says, using integration, write the first 4 terms in the general term of the power series for f of x equals ln of 1 plus x. So, McKenna, is this the type of question you're like, I looked at the homework, yeah, this seems really difficult. So let me help you here. You know how often I've said sometimes it's bad to be starting a question and hope to see the end from the beginning? Sometimes that's bad. I think in a case like this, that might actually be good. Here's what I'm thinking. I'm thinking if it says using integration, let's think of it from this perspective. If I wrote integral, let me do a better integral there. If I said integral of, I don't have a clue, integral of something equals natural log of 1 plus x, perhaps plus c, I don't know. I'm not going to be too worried about the plus c right now. If I wrote that out, what would you guys guess would go in for the question marks?
1 over 1 plus x.
That's right. Okay, so let's fill that out. So 1 over 1 plus x would go right there. Forgive the lack of plus c at this point. Interesting, right? Because Lenny points out this, hey, this integrand would have to be exactly that for this to work. And we're supposed to write this power series, the first 4 terms of it at least. Where have you seen that before?
1 over 1 minus x.
Yeah, that looks like a manipulation of the geometric series, right? So this is going to be kind of a multi-step process. If you can build this and then integrate it, I think you'd be there. So think just for a minute about what that might look like. I'll give you a little time to try it, and then I'll point out the steps, and then you'll get a chance to kind of try this again with the next one, with something different. If we could find the series for that integrand, it's just a question of being able to do the power rule a few times and you're done. So let's see if we can work towards that. So 1 over 1 minus x, as you guys can see on the board, of course, is just the geometric series, like so, plus dot, 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 x to the n. So then what would I need to do to turn this into that integrand that I really want? Substitution. Negative x. That's right. So it'd be 1 over 1 minus negative x equals basically just the alternating version of what we already had. And something like that. So that's the series that I want. And maybe what I could do at this point is say minus minus is really plus a positive. So I'm one step away now, right? If I can just take this and integrate the left side and integrate the right side, then I'm going to have exactly what I want. So it's going to be on the left, natural log of 1 plus x equals x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4 plus dot, 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 plus, still alternating. But then to get that nth term, can't you just integrate the nth term? So it'd be x to the n plus 1, all divided by n plus 1. So that's kind of a multi-step, right? You got to figure out the series that you're going to need to use to integrate to end up with the thing you're supposed to get. So it's kind of two things going on at the same time. Okay. Let's try the next one. The next one I'm just going to let you try totally by yourselves. Oh, interval of convergence. Didn't say anything about that. Let's find out. So we can run a ratio test if we want. I'm guessing because we integrated, I'm guessing the centering point obviously didn't change. Radius, I'm guessing, didn't change. We could run a full ratio test to decide that. But I'm guessing we're going to get negative 1 to 1. And I don't know about these. Right here. Yeah. So well, let's see here. I think we're going to see that come through when we test the endpoint anyways. So for x equals negative 1, we would get sigma from, let's see here, what would it be? Be 0 to infinity, and it would be negative 1 to the n times negative 1 to the n plus 1. Interesting. Over n plus 1. So Darian, you said it can't be negative 1 because ln of negative 1 plus 1 would be ln of 0, which does not exist, right? Right. So if you try a negative 1 here, what's interesting is I'm getting an alternating harmonic. You see it? No. If you plug in a 0 here and here, you'd get 1 times negative 1. You know what? No, hold on. So you get a negative 1 over n plus 1. But then if you plug in a 1, you know what? It's not alternating. Okay. It's just a negative harmonic. Right. So it diverges because it's a harmonic. There we go.
Yeah, why is it not alternating?
So try out just start plugging in terms, or plugging in n values. So if you plug in a 0, wouldn't you get 1 times negative 1 in the top?
That's just negative.
So it'd be negative 1 over 1. If you plug in a 1, you get negative 1 times 1 over 2. If you plug in a 2, you're going to get 1 times negative 1. this time over 3. So every single term will be negative if you start testing them out. So you basically just get a negative harmonic. So just a harmonic just on the bottom of the x-axis instead of the top. So it's still going to diverge. But I think if you try out the other one, if you try out x equals positive 1, you get sigma of negative 1 to the n times 1 to the n plus 1. I think this one actually will alternate, won't it?
Yeah, it does.
And over n plus 1. So I think this would converge because it's an alternating harmonic. So I think our ending interval of convergence would be negative 1 to closed on 1 for the final interval.
Question.
Yeah.
Why do the society start at n equals 0 to infinity? Like,
So I looked at this and this and asked myself, what would my n value have to start at for that to be true?
okay.
So,
Yeah.
so if I start the n at 0, my first term would be just x. So it really,
Makes sense.
it could be anything really.
Yeah.
I just thought, you know what, to make it match, okay, it's got to be 0. Yeah. Okay, so if you haven't already looked at 14, I think you'll find 14 to be similar to 13. You're going to have to use a known series and some integration, but this time we're heading for arctan instead of natural log. So, really similar. See how you do. Think back to arctan and integrals and how all those things work together.
Because arctangent, the derivative of arctangent is 1 over 1 plus x squared.
1 over 1 plus x squared.
Yeah.
It's 1 plus x squared, so wouldn't you just substitute with an x squared?
Yeah.
Okay, we got it. Possible. Okay, let me check over.
Isn't negative x squared to the n just negative x to the 2n?
Yeah, no, I'm just looking at this. Okay, I think that looks good. Now you got your last step. Just
What did you get to?
Negative x squared to the n just the same as negative x squared to the 2n?
Just
Or-
integrate the general
Yeah,
term.
take out the
So like when you
alternating
have,
I took the alternating, so I got negative 1 to the n times x to the 2.
so I would maybe, I would write this
But how do you
as
integrate
2n,
this?
right, because you got a base to a power already multiplied. So then.
If you take the, and,
think of
yeah,
this as
integral of this,
just
you said you got
Okay,
arctan.
okay, because I was just confused about this.
2n, so this is
Yeah,
just,
but
this
then,
is 2n
because
plus
you're integrating with
1
respect to
over
x, so negative 1 to n, negative 1 to the n will really just function as a
Plus
constant
one.
interval. So then just treat that x to the 2n as a power rule. And then I always go back and check and make sure, okay, does my f term really agree? You know, if I started at 0 or 1 or whatever on sigma, does it really agree? It should.
But the negative 1 to the n stays the same, you don't.
Wait, yeah.
Right.
How do you
Right, 'cause you're
integrate x to
integrating,
the 2n?
so technically your
It's like
integral is
natural.
integral dx.
Because n is going to be a
And so
constant.
since the integral
Two
dx,
n plus
anything that
one.
doesn't have an x in
Over
it,
2n plus
can just be- or any multiple can just be.
It was just me, but, oh, this is very
Cameron, how you
similar
doing?
to,
Okay. Okay.
sine.
It's just missing the factorial.
Yeah, it's only missing the factorial.
Did you write down what's the relation again?
Swim season right now?
Pretty good. We have our first meet tomorrow. She's practice every day after school.
You get less sleep.
Occasionally, I mean, we had more lifting this morning. It's like, I guess 2 days of the week I get less sleep.
Yeah. So you guys just swim in the afternoons only? Not
Yeah.
like morning or
So,
afternoon?
like, yeah, we lift in the mornings and in the afternoon, but most of the time I'll just lift by myself, like, more often. If they only do it twice a week, I want to try to do it 3 times a week at least.
Twice a week. So not that
It's
much.
weird timing, yeah, too, like Monday and Thursday. Monday, Wednesday, Friday would work easier for me.
Yeah, just get regular. Interesting. And is it a dual meet?
I'm not, that's a quad meet.
Quad, okay,
You know,
gotcha.
three other teams.
Okay, so you guys are all looking like maybe we're good? Yes, ma'am.
I have a question on the integral conversions.
Sure.
So I think we talked about this the other day, where you have like the square root of the negative two integral conversions. How do you, I like, know we did something with the ratio test.
So, yeah, my suggestion there, like when you look at that, you're like, oh my gosh, how's this gonna work with negatives, sort of negatives?
Think of it, it's the exact same thing as sine without the factorial, so you can the exact same choose the sequence. So like this, I guess it works, so when you, because when you plug in the n, you get the exact same thing as the
So
sine.
it should be less than one.
Yeah, just try to plug in the one.
Over 2n plus 2
So technically, so
You get
n
negative
plus
x
one
squared
means you're
over
gonna
n
do
plus
n
one.
plus one over n. So that would technically be two n plus
You have to
two plus
distribute.
one.
Oh, okay. Okay.
Yeah, so I would just rerun a ratio
Okay.
test and get my.
You still have zero.
Radius and endpoints and just make sure that. Okay, let's check this one out.
X over 0, x over 1, which is x.
Did you all use, you guys all use the geometric to start? So, from the perspective of looking at the end from the beginning, did you guys all start with this in mind? Was that kind of your general plan? No? Does that make sense? So this is going back to old stuff, right? This is going back to first semester antiderivatives. So you're going to recognize, how would I integrate something to get to arctan? It's got to be the integral of 1 over 1 plus x squared. Okay, so this is a connection back to first semester for sure. So then maybe the next question would be, how then do I get a series for this? Well, you'd need to use the geometric series to start. So the geometric series, of course, is 1 over 1 minus x equals, it's the easiest one, right? 1 plus x squared plus x cubed plus x to the n. So then how would I get that to turn into 1 over 1 plus x squared? Is it a multiplication, substitution, integration, differentiation? It's a substitution, and what do I substitute in? And we've done this, right? We've done this once before. We just didn't go as far as we have to go here. So it's going to be 1 over 1 minus negative x squared. It's going to turn this into an alternating series. So it'll be 1 minus x squared plus x to the 4th minus x to the 6th plus, and it'll be, you could write it as negative 1 to the n, x to the 2n, I think is probably the most convenient way to do this. You could write it as x to the n to the 2, but I think I would just go ahead and multiply those exponents like so. Okay, so once you've gotten to this place, it's a matter of doing the integral. So I'm going to integrate with respect to x on both sides. So this will give me arctan, which is what I wanted, arctangent of x. And that'll equal x minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7 plus ... Still going to be negative 1 to the n, but now it's going to be x to the 2n plus 1 over 2n plus 1. And just a reminder with these, it honestly, you know what, if you look at this, it really didn't say that you had to use a known series for this. You could have used the Maclaurin construction, right? You could have found f of 0, f prime of 0, f double prime, f triple prime of 0, and built it out that way. And you might look at that at first and be like, well, gosh, I think that's easier. I think once you get into like that third and fourth derivatives, perhaps, you would not feel the same way because those would just keep expanding into bigger and bigger product rules eventually. And I think you would say, well, gosh, it would be a lot easier if I just had remembered this in the first place. Yeah.
So will, like the AP test, will it be like this, where it says using integration opposed to saying use a known series?
Usually they frame it like that.
Okay.
Um,
So they give you the option.
if it's multiple choice, who cares? Do whatever you need to do. But in a free response, I'm sure they would frame it in a way to get you to do the thing they want you to do.
Okay.
Yeah. Yeah, I can think of a couple like that where they're like, they do kind of like say, oh, essentially, step 1, can you do this?
Right.
Step 2, let's put it together and do that. And step 3, here's a final product, like that kind
I
of thing.
just didn't know on like a free response, they would give you the option to do either, or if they wanted you to like do these series.
Yeah, a lot of times they do leave it sort of open as long as your math is correct math.
Okay.
They really do. They in a lot of cases they do leave it pretty open, which could be a good or bad thing, right? If you
Right.
choose the longer path, it could take you forever. But if you see this, it's over pretty quick.
Yeah.
Yeah, good question. Interval of convergence. Alyssa brought this up, and I think it's a good point. Alyssa said, hey, we get this thing again, where you essentially get this, where if you were going to solve for x in the interval of convergence, you'd have to do the square root of a negative. And so this might be one of those cases where it's going to be more beneficial to just rerun a ratio test here and decide what the interval of convergence is. And I don't know if I've got enough time to finish all that here. At the very least, I'll set it up for you. I would go limit as n goes towards infinity of the n plus 1th term would end up being x to the 2n plus 2 plus 1, so plus 3. And then 2n plus 3 down there. It'd be times 2n plus 1. There should be a 2n. Over x to the 2n plus 1. I think when all is said and done here, I think you're going to end up with absolute value of x squared is less than 1. So I think you're going to end up here. You're just going to need to test your endpoints out in each of those to decide is it open or closed. Looks like it's going to be closed on the 1 and open on the negative 1. Just taking a quick glance at it, I think you're going to get a harmonic on the left edge and an alternating harmonic on the right edge as you test those out. So, hey, to close this off, is everybody on board with McKenna's proposal? Or are there some dissenters? So maybe something you could do then, so I'll probably make that probably right now. So maybe something you could do, McKenna was particularly concerned about the homeworks and saying, I feel like there's some tough ones in there. If you want, maybe something that you could bring on Monday, since if we're not going to have regular class on Monday, if it's just going to be more Q&A review, maybe try as many of those as you can. Bring questions. We can work on the rest of them during that period. If something awesome happens and you all work through those and you're like, actually, I only have one question, it's not that hard, I certainly have plenty of other materials we could practice with. So, all right. We'll look for an update or an email or something about that. Have a great weekend.